Hello students and welcome to the lecture. So students, as we know that in the previous lecture, we had started our discussion over the work, power and energy. That was our part 1. This is going to be our part 2. Okay. In this lecture, basically we will continue with this topic further. In the previous lecture, basically we had discussed over the work, power, like what is the definition of these two in the terms of physics. How do we measure them? What is the units of these? Also, we have taken the example of energy. Like the conservation examples, we have taken an overview of the energy. Also, we have gone through the law of conservation of mechanical energy. I hope you have revised that lecture in the well enough manner before you have come for this lecture. As many times I have told you, that is for your own benefit. If you are doing this on the regular basis, think will be in your favor when you give to your exam. If you are not doing this on the regular basis, think might be or may be against you when you give your examination. Okay. In this lecture, we are going to discuss about the laws of conservation of energy, mass energy equivalence, sources of energy, classification of source of energy, fossil fuels, energy from biomass, solar energy, solar cookers, solar cells, geothermal energy, nuclear energy. At last, we will see the summary of all of these. So this is going to be the topics that we are going to be discussing. But before starting, as usual, we have our small disclaimer over here that we are required to understand before we proceed further. So a disclaimer is like, the images used in a slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck, have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. Now, let's begin with the laws of conservation of energy. According to the law of conservation of energy, the energy could neither be created nor it could be destroyed. Again, I'm repeating, energy could neither be created nor it could be destroyed, which means the energy is always there. It is not created by anyone. It could not be destroyed by anyone. It is there. Okay. In other words, we could say the total energy of a closed or isolated system. When we say the closed or isolated system, basically we are assuming that this system is not having any contact with the outside, so that the change or exchange of energy is not going on with that system. So the total energy of the system will remain the same. Okay. That will not be decreased or increased because no energy is being created so that the energy could be increased. No energy is being destroyed so that the energy could be decreased. The energy will remain as it is. The sum of various energies in the universe remains constant. That's why. Okay. After this, we have finished the law of conservation of energy. That is simply says that the energy could not be created, could not be destroyed. It is always there. Okay. Now we are going to talk about the mass energy equivalence. So basically that was the year of 1905 when a famous scientist called Albert Einstein, or Einstein in short, he proved the equivalence of mass and energy. Okay. He proved the equivalence, mass and energy. He showed that mass m could be converted into energy E, which is given by E is equal to mc square. Okay. Where c is the velocity of light. Most of the energy of the universe, such as the energy from the sun and the stars, come from the conversion of mass into energy. So basically, in 1905, he said the mass of an object could be converted into the energy. Okay. And to establish this concept, he gave us E is equal to mc square, that is famously known as the theory of relativity also. Okay. And here we can say E is represent energy, M represent mass. What about C? What is C being represented here? So C is basically here the velocity of light. Got it? That's why it is said C square. So he said, because universe is also taken as an isolated or closed system as per the law of conservation of energy that we have just seen right now. So the energy that is coming from the sun and the stars, okay, in the form of light. This is actually the mass of these areas or these bodies, like the mass of sun and the mass of star. This is being converted into the energy. Okay. So E is equal to mc square is being applied to them as per the Albert Einstein in 1905. It is famously known as the mass energy equivalence. Okay. This equation is known as the Einstein formula of mass energy equivalence. Okay. And please be careful. It is mass energy, not mass energy. Okay. Note the relation E is equal to mc square leads to the unification of the two laws. First law is law of conservation of mass. And second is law of conservation of energy. Got it? So before understanding this, first we understand what does the law of conservation of mass says, what does the law of conservation of energy says. So basically, if we talk about the first one, that is the law of conservation of mass, it simply says mass could not be created, neither be destroyed. Or you can say mass neither be created nor be destroyed. Okay. Similar application being applied with the law of conservation of energy. Energy neither be created nor be destroyed. Okay. So basically, these two laws are dealing with the other things. Law of conservation of mass dealing with the mass, law of conservation of energy dealing with the energy. But when Einstein in 1905 gave his mass energy equivalence or the theory of relativity E is equal to mc square, basically he unified these two laws, the law of conservation of mass and the law of conservation of energy, into a one single law that is now known as the law of conservation of mass energy. Got it? So here we have the first conservative forces. So what are the conservative forces? First we have to understand, then we will take a look on the non-conservative forces also too. So first is the conservative forces. So a force is said to be a conservative if the work done by the force in moving a body between any two points is actually independent of the path followed. Okay? Or a force is said to be conservation if the work done by the force in moving a particle along a closed path is zero. So in these two conditions, it is sold as a conservative force. First conditions, just read it again. Any force could be said as a conservative force if work done by the force in moving a body between any two points is actually independent of the path followed. The force is not following the path. The force is independent. Okay? And a force is said to be conservative in the another sense. Work done by the force in moving a particle along a closed path is zero. In these two conditions, that will be known as the conservative force. For example, the gravitational force, the electrostatic force, the elastic force. These forces are conservative. Why? Because they are independent of the path being followed. And whatever the work they done by moving a particle along, they doing it as a closed path, and this is zero. Now, the non-conservative forces. On the other hand, the non-conservative forces are if the work done by a force in moving a body over a closed path is non-zero and the force is said to be non-conservative force. Like when it is zero, conservative force, non-zero, non-conservative force. Just an opposite. Example, frictional force. Got it? Now, after this mass energy equivalence, we have the sources of energy. Like we know, Basically, we have defined the energy as a you can say the rate of doing work, right? That is what we have defined as the energy. Now, from where or from which sources we generate that energy, that is the another thing. Okay. So if we talk about the sources of energy, a source of energy is actually one which could provide the adequate amount of energy in a convenient form over a long period of time. Like you can say, any source which we are going to define as the energy source must be able to provide the adequate amount, which means the amount that we require, that amount we must obtain from that source also in a convenient form. It means in a form that we could utilize easily, not for short period but for a long period of time. Then it is known as the source of energy. Got it? In fact, all our everyday activities that we usually do is actually using the energy in one form or the other. If there is no energy, all our activities will come to stop. Why? Because whatever activities we are doing, we are actually doing a work. And energy is basically providing us the capacity, providing us the power so that we could do the work. Okay. Here, kindly do not get confused between the power concept that we have covered in the previous lecture with this power word, which I'm just saying to you. Okay. Basically, here I am trying to align the capacity and the power. If you having a power, you can do work. If you having the capacity, you can do work. Both the things are basically related with the energy. If you having the energy, in short, you could do the work, you could perform the activities. Not having the energy, no activities you could perform. Okay. So basically, good sources of energy having the following characteristics. Like by following which characteristics we could say that this particular source that we are seeing being here, it is the good source. That particular source that we are seeing over here, not a good source. So basically, for the good source of energy, the first criteria is high energy output per unit volume. Okay. Like if we consider the per unit volume, the energy output that we are receiving from the source is higher. Thereafter, steady availability, which means it's basically for the long period of time, not for the short period of time. You use the energy for one day, another day it is empty. That is not the source of energy. If you are using these for the long duration, then only it will be a source of energy. So it must be steady, available, safe and easy to use, convenient form. Okay. Easy to store and transport so that our convenient form could be utilized. Economical. Okay. Like you can say, if we know there is a source of energy from where we could generate an adequate amount of energy for a long period of time. But the input cost, which means that the costs that have been occurring, including your efforts, your time, your money to get out this energy, is much more higher than we could not sustain it for even a short duration. Then what you can say? It is economical or non-economical? Clearly, it is non-economical. Why? Why it is non-economical? Because that thing that we are going to do with this is not a convenient form. Okay, we required a convenient form, then only we could utilize it for a long period of time. Otherwise, we will get finished. Okay. Now, how do we classify the source of energy? All these sources of energy could be managed into the two main categories. Okay, there are the two main sources of energy or two main areas from where we could obtain energy. First, renewable source of energy. Second, non-renewable source of energy. Only two: renewable source of energy, non-renewable source of energy. First, if we talk about, it's a renewable source of energy. Those sources of energy which are being produced continuously in nature and are inexhaustible, these are called the source of energy, which means that Naturally, they are being produced, and these are inexhaustible, which means that they could not be exhausted, and they could be used forever. Then these are the renewable, which means they could be renewed after the use. Second example are wood is a renewable source of energy because if trees are cut from the forest for obtaining wood, then more trees will grow in the forest in due course of time, which means that the wood and its availability could be utilized effectively. Okay. In other renewable source of energies are solar energy, wind energy, hydro energy, biofuels, hydrogen, energy from oceans, geothermal energy. These are also the renewable source of energy and also called the non-conventional source of energy. Why these are known as the non-conventional source of energy? Because non-conventional and conventional, you can say conventional source of energy are those energies which we have been using for a long duration. Okay. And generally we use the conventional source of energy in terms of the non-renewable source of energy. Okay. Conventional source of energy are the innovative sources that we could utilize. Okay. That's why these are known as the non-conventional and renewable source. Okay. These sources of energy could be used again and again endlessly because these are naturally produced in the nature and inexhaustible. Okay. They will never get exhausted. Thereafter, we have the non-renewable source of energy. Those sources of energy which having accumulated in nature over a very long time and couldn't be quickly replaced when exhausted, these are called the non-renewable sources of energy, which means the sources not produced naturally. These sources have been accumulated in nature after taking a very, very long duration while the processing. These are known as the non-renewable source of energy. And these are exhausted. Why? Because the time taken in making of this is much more higher in comparison with the time taken in utilizing it. For example, if we talk about petroleum, nearly petroleum takes 100 million years to get accumulated beside the earth. Okay. And we use petroleum in daily life, which means the rate of consumption of petroleum is much, much, much higher in comparison with the rate of making of the petroleum. So that's why it is said when they got exhausted once, they are not that much quickly replaced. Why? Because they are taking very, very long time for accumulation. Got it? For example, coal is non-renewable source of energy because coal having accumulated in the earth over a very, very long time. And if all the coal gets exhausted, it couldn't be produced quickly in nature because it took very much years, very much time or very many years to be produced. Got it? Other non-renewable sources of energy, if we go back, petroleum and natural gas, etc., because they also take a long time while accumulation or formation, and they could be utilized easily or rapidly. After this, the fossil fuels, if we talk about, so fuels that originated from the remains of dead plants and animals, these are known as the fossil fuels. Okay. Coal, petroleum, and natural gas, these are the fossil fuels. Why? Because these have been obtained from the dead plants and animals who have died millions of years ago. And over the time period of this million years, through the processing, those dead plants and animals got converted into coal, petroleum, and natural gas. And now we are getting them as a fossil fuel. These are also conventional and non-renewable. Why? Conventional, why? Because we have been using them since the starting, or conventionally or traditionally. These are non-renewable. Why? Because the time taken while formation of these fuels is much more higher in comparison with the time taken while consuming these fuels. Okay. Burning them also causes the air pollution. Why? Because these contain some, you can say, hazards or dangerous substances like oxides of nitrogen and sulfur. Okay, because of this, the air pollution creates when we burn them. The pollutants produce including carbon dioxide, carbon monoxide, oxides of nitrogen, sulfur, which I have just told you, and these are harmful for our atmosphere as well as human health. The oxides of nitrogen and sulfur cause acid rain. Why? Because when they remain in the air and whenever the rains happen, basically the droplet of rainwater got mixed with this oxides of nitrogen and sulfur and forms into a acidic droplet. Okay, and this causes the acid rain. Natural gas is the cleanest fossil fuels that we have ever found. Why? Because natural gas do not produce the carbon dioxide, carbon monoxide, and also the oxides of nitrogen and sulfur. That's why it is cleanest. It is not that much polluted. Okay. Now, if we talk about the energy from biomass, how it is being obtained. So, in the context of energy production, biomass means any organic matter from which we could get energy on a renewable basis. Okay, that is the biomass energy. Wood is also a biomass fuel. Wood could be more efficiently utilized by converting it into the charcoal after burning. And biogas is combustible mixture of gases produced by decomposition of biomass. Like suppose you have converted the wood into a charcoal, becomes a biomass. When you burn it, so basically you are decomposing that biomass, and that biomass is giving you a mixture of gases that is combustible, and it is commonly known as the biogas. Got it? It is produced by the anaerobic digestion of biomass such as cattle dung, sewage, etc. Biogas could contain up to 75% methane, 23% carbon dioxide, and 2% other gases, including the hydrogen and hydrogen sulfide. That's why it is said it's a mixture of gases. This combustible mixture is an excellent renewable fuel that could be used for electricity generation and for cooking also. Now the energy from biomass. What is the advantage of biomass? So we could say biogas plants are simple. Biogas is an excellent clean fuel that burns without producing ash and smoke. The spent slurry is also a good manure. Biogas plants are safe and useful way of waste disposal. Use of biogas leads to saving of firewood and reduces deforestation. Okay. Now after this we have the solar energy to be discussed. The energy which is received from the sun is called as a solar energy. Okay. The sun is the ultimate source of energy of fossil fuels, flowing water, wind, biomass, and ocean water. Because as we know, everything requires energy to perform its task, and basically the solar energy that we are using is coming from the sun. That's why sun is the ultimate source of energy for fossil fuels, for the flowing of water, wind, biomass, and ocean water. The energy that the near Earth space receives from the sun is about 1.4 kilojoules per second per square meter, and this quantity is called the solar constant because this will remain same. Now we know that the unit of kilojoules per second is equal to kilowatt. So we could also write the value of solar constant in terms of power by writing kilowatt per square meter in place of kilojoules per second per square meter. Thus, solar is constant is equal to 1.4 kilowatt and mm square. Okay. About 1/3 portion of the sunlight consists of infrared rays. These infrared rays have a property that they heat the objects on which they fall. Okay. Like you can say if you're having any object, you place it in presence of sunlight, that object will receive the solar energy through the infrared and that object will become heat up. Right. So when sunlight falls on an object produces heat, and this heat could be used for various purposes. It is the infrared rays which heat up the earth and water also on the surface of Earth. Okay. Infrared rays are emitted by all hot objects. The wavelength of infrared rays emitted by a hot body depends on its temperature. Higher the temperature of a hot body, shorter will be the wavelength of infrared emitted by it. There is a note. The infrared rays could be detected by heating effect by using a thermometer with a blackened bulb. A solar heating device use solar energy to heat the things. For example, solar cookers. Here you can see it. Okay. Now, a box type solar cooker is an insulated airtight box covered with glass. Its inner surface is painted black and having a plane mirror to increase incident sunlight so that the more energy could be generated. Solar energy is ineffective in winters and on cloudy days. Why? Because the amount of sunlight that is being projected here will be less. Now the solar cells, a device which converts the solar energy into electricity is called a solar cell. Solar cell made from the semiconductors like silicon. In a solar panel, a large number of solar cells are connected to get a large potential difference in current. Solar cells also used in calculators, watches, artificial satellites, and in providing electricity in remote areas to run such things as pumps, telephones, light, etc. Now, geothermal energy. Geothermal energy is actually the energy stored as heat in the earth. We know the earth having a cool surface but hot interior. Okay, so the hotness of the earth interior contains energy that is known as the geothermal energy. Geo means earth, thermal means heat. Okay, it heats rocks and water below the ground. Above hot spots, dry steam or a mixture of steam and hot water comes out from the. This hot steam could be utilized directly to turn turbines. At another places, different methods are used to get steam from the underground hot water. Now, nuclear energy. If we talk about it, so we could say the process of heavy nucleus splitting into two middleweight nuclei is actually called the nuclear fission. U-235 absorbs a slow neutron to become the U-236, splits fission to give about 26 mega eV of energy. A reaction that continues on its own as one occurrence of the reaction triggers the next occurrence is called a chain reaction. Control chain reaction is used in nuclear power plants. There is a note. The process of two or more light nuclei combining to form a heavy nucleus is actually called the nuclear fission. Energy in the sun is produced by the fusion, not by the fission, of hydrogen into helium. The high temperature, about 10⁻⁷ Kelvin, required for the fusion. Here we have finished the topic, not part for the summary discussion. We have talked about the law of conservation of energy, Einstein's mass energy equivalence, conservative forces, non-conservative forces, how the energy sources are being categorized into the renewable and non-renewable, what are the renewable sources, what are the non-renewable sources, what are the fossil fuels, biomass, biogas, and etc. Solar energy we have talked about, solar cells we have talked about, geothermal energy we have talked about, nuclear fission and nuclear energy we have talked about, and nuclear fission also we have talked about. With this, we have finished this lecture. It is requested to all of you, kindly revise the facts and figures that all we have discussed in this lecture and keep yourself ready for the next lecture. With this note, let's end this lecture and thank you.